Okay, let's look at a more difficult problem. Right? Roughly the same idea. We're still factoring a polynomial, a trinomial to be exact. And the only difference is now I'm going to have a leading coefficient, a coefficient for my x squared term. Right? But the process is going to be the same, so I want to start with the same idea and look at a problem where we foil it together first and then try to unfoil it and break it apart. So again, this should be a quick recap of foiling. Distribute the 3x, distribute the 2. Okay, 3x times x. 3x squared. 3x times 3, that's a positive 9x. 2 times x, positive 2x. And 2 times 3, positive 6. And combine our middle two pieces, and we have 3x squared plus 11x plus 6. Okay, so not a problem at all to FOIL that out. There's nothing special. Okay, but now if I wanted to factor, okay, if I said factor 3x squared plus 11x plus 6, that would mean we want to break it apart into where it came from. So here's our answer. We already know what it is. But let's see why this becomes a little bit more difficult. Right, our first question that we ask ourselves, as always, right, now that specifically there's a coefficient with the first term, we might have a common factor. Right? But if I'm looking at 3, 11, and 6, I don't see any significant number that's going to work. So again, I want to point out there's no GCF in this case. And again, if there's no GCF, our only option for this class is to say, well, I'm going to factor this by unfoiling. Now, we look to the first term, and the first term becomes more complicated because we have a coefficient now. Right, if it was just x squared, we remember that it has to be an x and an x. That idea still holds, but since it's 3x squared, we need to worry about this 3 because these two numbers that belong here have to multiply together to get 3. So we have to play the same game in the front as we do in the back. That 3, right? Where does that possibly come from? Well, the only option is 3 times 1. Clearly, this is a nice example because I only have one option, so I know that this has to be 3 and 1x. When this number gets more complicated, say this number is a 12, then you have possibilities for our beginning, and that would be 3x and 4x, 6x and 2x, 12x and 1x. That makes it even more troubling to start this problem because we don't know exactly where we begin. But when we only have one option, I would consider this a nice version of this problem. And we know exactly where we're starting. All right, next, we look at 6, just like we've done before, and we say, well, I still need two numbers back here that are going to multiply to get 6. All right, so our options are 6 and 1, or 3 and 2. Not many options. All right, but if you'll notice, none of these options add up to 11. So this is where this becomes a little more difficult. It's not as straightforward where I can just look at these pairs or think about just those pairs and try to add up to 11. In fact, if there even was a pair that added up to 11, it doesn't mean that that's the pair that's going to work in this scenario. I would say it's even more likely that that pair is not going to work. Right? The reason being is because this 3 that we've already placed in this problem dramatically affects the product when we multiply it out. When we FOIL this out, this 3 is going to have an effect not on just the 3x squared term, but on this middle term as well. Because notice, whatever number we place in this back spot, when we FOIL it out, is going to be multiplied by 3. So that's the issue here, is that this number, right, has to be multiplied by 3. So what I like to do is I like to just fiddle around with all 4 of these numbers and see which pair can help me out the most in this back spot, because it's going to be affected by the 3. Right now, I'm just going to do it wrong so you can see and maybe learn something from what would happen if you didn't know how this problem was going to end. Clearly, we know how this problem is going to end, but if you just had no idea how this FOILing process worked and you just wanted to take a guess, right? which is possible. Sometimes you're going to run into a scenario where like, I don't see it happening. Well, if that's the case, I suggest just pick an option. Let me pick 6 and 1. Right, you might think that this is 6 is closer to 11 than 3 and 2, so maybe I need to use a 6. Well, let's see what would happen. If I put the 6 back here and the 1 up front, right, how would this pan out? Right, I always like to check the middle term. Because we know when we put the 3x and the x in here, we know that we've guaranteed ourselves 3x times x is 3x squared. So we know this term is checked off. I don't have to worry about it. And we know when we put the 1 and 6 here, 1 times 6 is 6. We know this term is checked off. I don't have to worry about it. The only term I have to worry about is this middle term. So in my mind, I'm checking middle term success. All right, and to do that, right, as I pointed out before, remember, how does this middle term come about? It comes from the outside and the inside multiplication steps. Right? 3x times 3 is 9x. 2 times x is 2x. So it's the outside and the inside. So when I'm doing this, I check outside and inside. I don't put any signs in yet. I just want to double check. Do these two pieces allow me to get near 11? So 3x times 6, that would be 18x. And on the inside, I have just a 1x. Right? Can 18x and 1x, if I group them together, can they help me get to 11? No, the answer is no. Remember from before, when we have a pair, right, we can add them up and they can get me to 19x, or we can subtract them, 18 minus 1, and get to 17x. Right, either positive or negative. So if this middle term happened to be 19 or 17, then this would be the correct way to go. Right, but since it's not, right, those are not helpful. So then we go back to the drawing board and we try again. Right, in these situations, it is very important where the number is placed. That in fact makes a difference, whereas before it didn't. If I put the 6 here and the 1 here, if I switch this around, right, now we're going to have different possibilities of a middle term. Still, it's not going to get us the right answer, but at least we can learn something from it and say, if I check my middle term here, the outside, 3x and 1, that would just be a 3x. Right, my inside pieces is a 6x. So with 3x and 6x, if we added these together, I could get 9x, or if I subtracted them, I could get 3x. Right, but still, none of those happen to be 11x, so we're going to say, I don't want to try that one either. So we've tried 1 and 6 and 6 and 1, and since neither of those combinations worked, we know this pair is no good. Back to the drawing board. Right? When we do more practice problems, we're not obviously going to get them wrong as many times, because we're going to be more efficient guessers. Right? I wouldn't even call it guessing. I'd say it's a hypothesis. We're educated. And we know what we're doing. We can see what's going to happen, so we don't have to make these mistakes every time, but sometimes you will. Again, here, if we went with our option 3 and 2, but we put 3 and 2 here, right, my middle term would pan out to be, again, 3x times 2, that'd be a 6x, and a 3x. Right, look, it's the same as up here, right, but still no good. Right, this is a no good option. These only add up to 9 or 3. So we're left to our last option, so our last resort. Right, if this doesn't work, then we're then something went wrong along the way. So the only other option is to flip these around. Right, check our middle term. Right, that'd be 3x times 3 is 9x with a 2x in the middle. Right, and bingo, these can add up to 11, or they could potentially subtract to 7. Right, so if this middle term is 11 or 7, then this would be the one to go with. So bingo, we found it. Now, at the last point, again, as always, I like to put in the signs last to figure out how could I add these up to 11. And we saw this trick from before. If everything's positive in the problem, right, it definitely has to be positive for this to work. And we are right, down to our factored form. 3x plus 2 times x plus 3. There it is. All right, so that example took a decent amount of time because I made so many mistakes, but hopefully we learned something from those mistakes, and going forward in the next video we'll do some practice problems where we see how we can be a little more efficient with this.